Okay, fifth degree polynomial, far more difficult to deal with. What's nice about it though is the potential rational roots is quite limited. It's going to be basically the factors of 18, which is fairly easy to write down. Now granted, it's more difficult to deal with these numbers because it's the fifth degree, but I'll be honest with you, you'll be able to stumble on it pretty quickly. F of 3 would be equal to 0. Now, someone says, what are you going to do now? Well, if this is true, right, and 3 is a root, I know a factor of x minus 3. What I would do is I would long divide into that. Someone says, why would you do that? It makes it easier for me to analyze the resulting depressed polynomial. So I divide x minus 3 into it, and then I get this one over here. This one's easier to deal with, and I'll tell you why. It's fourth degree, and the list of potential rational roots is just 1, 2, 3, and 6. All right? Now again, it's easier to deal with a fourth degree polynomial than a fifth degree polynomial. Now, unfortunately for this one over here, I don't stumble upon the root until I get to this one over here. All right? And then what do you get? Well, you get this over here. I have two roots now, and the two roots are as follows. One was 3, so I get the factor x minus 3. And the other factor I get is x plus 6 now. What am I going to do? I'm going to divide this now by x plus 6. That's right over here. And then I get this depressed cubic here. This only has two possible rational roots, plus or minus 1. Unfortunately, neither works. If you try 1, right, if I tried x to be 1, what would that give me? 1 plus 5 minus 4 minus 1, which is 1. So this doesn't work. If you tried x equals minus 1, what would you get? Minus 1 plus 5 plus 4 minus 1, which clearly is not equal to 0. So neither work. So I got trouble here. Now, by the way, you may not recall this, but we did cover how to solve a cubic. All right, let me get my eraser out. And in the notes, I'm going to go back and read it to you. We got two of the factors already. Let's go back. It says find all commensurate roots. I did that already. I know what they are. They want to do the remaining roots when possible by methods already given. Well, we've given a method, if you recall, for solving a cubic. We've given a method over here. So let's review that. It's difficult. I wouldn't expect most people to remember what we did, but you can go back and review it. I want to remind you my name is Ron Bannon. My email address is Bannon, which is B as in boy, the at symbol, NNON.US. All right? So the quotient that I found, x cubed plus 5x squared minus 4x minus 1, has no rational roots. Remember, it had two candidates, plus or minus 1, and neither worked. We've tested them. All right? So you may want to go back to section 783 of the notes, and we did solve cubic equations of this form over here. What do? We had an equation like this over here, and we made a substitution. Now, granted, it's difficult, and I realize that it's difficult, but the bottom line is we've done it before, and I list the steps down for you, and then I go through the steps. And I know it's difficult, and is it ever difficult? So, boy, it's a lot of work, isn't it? But I put the work down here for you, and I found the three other roots. All right, three other roots I found. And I asked you, it was work. And if you want to go through that work, good for you. I did the work though. It was work. It was a lot of work for me too. It isn't like I look at that and say, gee whiz, this is obvious. This required a lot of work on my end. All right. So what I want to do is, basically look at the graph now. All right. Let's see if we can do it. And what's the graph going to be? Well, it's a really long problem, wasn't it? Well, I'm going to be looking for the roots 3 and minus 6. Let me go back to the graph. And let me outline that for you. Minus 6 and 3. All right? Now, it's a fifth degree polynomial. Oh, by the way, the y-intercept is 12. It's up here. It's a fifth degree polynomial. And boy, was it a lot of work to get those. I got to be even after getting them and all that work over there, it's really hard to visualize those. So what I'm going to claim over here is approximating them is not a bad idea, all right? So I approximated them for you. Yeah, it required a computer to do that. Minus 5.67, that's over here. The other one we got is minus 0.20, that's right over here. And last but not least, we got 0.88, which is right over here. Now it's a fifth degree polynomial, so we are expecting, with a leading coefficient of positive number, we're expecting this behavior here. The fact that I know the y-intercept, I'm expecting this behavior over here. Now granted, if you want to do sign analysis, you can, but I'm going to say you're expecting this behavior over here, and you're expecting this behavior over here, and you're expecting that behavior over there. Now granted, a machine did generate that picture, and the picture's not bad, all right? But you get a rough idea what it looks like by plotting the x and y intercepts and doing some basic sign analysis, and certainly information about the leading coefficients, repeated roots, things like that. Thank you.